Question 1. In how many ways a committee of 5 can be chosen from 10 students? You have 10 students and you have to choose 5 students from 10 students. Choosing means selection comes under combination. So different ways of choosing 5 people from 10 is 10C5, and that is 10 into 9 into 8 into 7 into 6, starting from 10 5 factors divided by, because it is C, divide by 5 factorial is extra, 5 into 4 into 3 into 2 into 1. And this will give you 252. Question 2. How many triangles can be formed from 8 non-collinear points? How many triangles can be formed from 8 non-collinear points? We had discussed a formula for number of triangles is NC3 minus KC3, where K stands for collinear points. If there are no collinear points, then this concept of subtraction is not there. So then the formula is only NC3. So therefore, the number of triangles formula is equal to NC3, and that is 8C3. So calculate 8 into 7 into 6, starting from 8 3 factors divided by 3 factorial, 3 into 2 into 1, so 6 gets cancelled, 8 into 7, that is 56. Question 3. Find the number of ways in which a committee of 4 students and 2 lecturers can be chosen out of 10 students and 8 lecturers. Let us see first what is given. How many people are there? Totally there are 10 students and there are 8 lecturers. I have to form a committee in such a way that I choose 4 students and 2 lecturers. So what do you notice here? From 10, I have to choose 4, and this can be done in 10C4 ways. And means into. From 8, I have to choose 2, and this can be done in 8C2 ways. So total selections is 10C4 into 8C2. Now we need to calculate what is 10C4. 10C4 is equal to 10 into 9 into 8 into 7 divided by 4 factorial, 4 into 3 into 2 into 1. If you calculate this one, you will get the answer as 210. Next, 8C2 is 8 into 7 divided by 2 factorial is 2 itself, and this when you calculate you will get 28. So here 10C4 into 8C2 is 210 into 28, which is equal to 5880. So total number of selection is 5880. Question 4. Find the number of straight lines and triangles that can be formed out of 20 points, of which 8 are collinear. We are given a total of 20 points, and the total points we take as n, collinear points we take as k, and this is equal to 8. We are asked to find the number of straight lines that can be formed using these points. So the formula for number of straight lines is NC2 minus KC2 plus 1. So this will be equal to 20C2 minus 8C2 plus 1. By now, I hope you know how to calculate these values 20C2 and 8C2. I'll just do it here at the side. 20C2 is 20 into 19 divided by 2 factorial, and that will give me 190, and 8C2 is equal to 8 into 7 divided by 2, and that will give me 28. So this is 190 minus 28 plus 1, which will be equal to 163. So we got number of straight lines is 163. Now we'll calculate number of triangles. What is the formula for number of triangles? Number of triangles, we know the formula is NC3 minus KC3. So this will be equal to 20C3 minus 8C3. Calculate 20C3 and 8C3 separately. You will get the answer as 1140 minus 56, which is equal to 1084. So this is number of triangles and this number of straight lines. Question 5. Find the number of parallelograms that can be formed from a set of 6 parallel lines intersecting another set of 4 parallel lines. M is equal to 6 intersecting another set of n parallel lines, so n is equal to 4. You are asked to find number of parallelograms. The formula for number of parallelograms is MC2 into NC2. So this is 6C2 into 4C2. Calculate what is 6C2. 6C2 is 6 into 5 divided by 2. You'll get it as 15. 4 into 3 divided by 2, and that will be 6. 15 into 6 is equal to 90. I assume by now you know how to do these calculations. If you do not know, refer back to the previous sums. You will understand how to calculate this. So that's why I've written the answers directly here. 15 into 6 is equal to 90. Question number 6. Find the number of diagonals of a polygon of 20 sides. We are asked to find the number of diagonals of a polygon of n sides. So n is equal to 20. You can directly use the formula for number of diagonals. Number of diagonals formula is n into n minus 3 by 2. Logically NC2 minus n. You can directly use this formula. N is equal to 20. So 20 into 20 minus 3 divided by 2. That is 20 into 17 by 2, which is equal to 170. Question 7. In a party, each person shakes hands with everyone else. If there are 25 members in the party, calculate the number of handshakes. Number of handshakes formula we have already discussed, and that is NC2. Number of people n is equal to 25. So the total number of handshakes is equal to NC2, that is 25C2, 25 into 24, starting from 25, 2 numbers divided by 2 factorial. And this will give us 300. Question 8. In how many ways can 6 red and 4 white marbles be chosen from a bag containing 10 red and 6 white marbles? So first let us see what is given. We are given a bag contains 10 red marbles and 6 white marbles. The question is, you have to choose 6 red marbles and 4 white marbles. So here asked to find how to choose 6 from 10 and 4 from 6. So different ways of choosing. From 10 choose 6, 10C6 and means into. From 6 choose 4, so 6C4. Now we need to calculate 10C6. To calculate 10C6, you can use that method or the formula. 10C6 is equivalent to 10C, 10 minus 6. 10 minus 6 is 4, 4 is smaller than 6, so less calculation. 10C4, and 10C4 is 10 into 9 into 8 into 7, starting from 10, 4 factors divided by 4 factorial. So this 8 gets cancelled, 3, so this becomes equal to 210. Next I need to calculate 6C4. Now 6C4 again, do 6 minus 4, 2. 2 is less than 4, so better to go for this formula. Let me apply it. 6C4 is same as calculating 6C2, starting from 6 two numbers divided by 2 factorial, and that is equal to 15. So now come back to the formula. Total number of selections is 10C6 into 6C4. 10C6 is 210 into 6C4 is 15, and when I multiply these two, I get 3150. Question 9. In how many ways can 6 people be chosen out of 10 people if one particular person is always included? So see this. Totally there are 10 people and we have to choose 6 people. You would have told the answer is 10C6, but there is a condition. What is that condition? Out of the 10, one person is already selected. So now out of this 10, split them, one person is already selected, then there are remaining 9. So this 10 people have split as 1 and 9. So this is the person who is already selected. So one selection is over. Totally I have to choose 6. If the total has to be 6, 1 is already over. I need how many more? I need 5 more. And those 5 have to be chosen from here, from the second group. From that one person who is already chosen, from the remaining 9, I have to choose 5. So the total selections is 9C5. 9 minus 5 is 4. So you can calculate 9C4 instead of 9C5. And 9C4 is 9 into 8 into 7 into 6 divided by 4 factorial, 4, 3, 2 and 1. So this is 8 gets cancelled. So that is 14 into 9 and that is 126. Question 10. If a convex polygon has 170 diagonals, find the number of sides of the polygon. Note this sum. You are given the number of diagonals is 170. And you are asked to find the number of sides. N is equal to how much? This is our question. We know the formula for number of diagonals. Number of diagonals n into n minus 3 divided by 2 is equal to 170. N into n minus 3 equal to 170 into 2 and that is 340. Again here, either you go for solving the quadratic equation or else you try by inspection method. Since you have calculators to be used, I think this inspection method would be easy. Substitute some values. If I put n equal to 10, 10 into 10 minus 3, that will be 10 into 7, 70. That's not the answer. Go for a higher value. Supposing I put n equal to 20, this is 20 into 20 minus 3 is 17 is equal to 340. So I can conclude n is equal to 20. So the number of sides is equal to 20. Question 11. A committee of 4 has to be chosen from 10 boys and 8 girls. In how many ways can this be done if the girls are in majority? Let us see what is given. Totally there are 10 boys. There are 10 boys and there are 8 girls. I have to choose a committee of 4 people. So the total people should be 4. I have to totally choose 4 people. What is my condition? The condition is the girls should be in majority. So the number of girls should be more. It cannot be equal. It has to be more than the number of boys. I have to choose 4. Let me start with the maximum value. Maximum is 4 itself. If I have all the 4 are girls, then the number of boys will be 0. Is this the only possibility? No. There is another case. What if I have 3 girls? My total should be 4. If there are 3 girls, then I should have 1 boy. Next, if I take 2 girls, then it will be 2 boys to make it a total of 4. And 2 and 2 means they are equal, they are not in majority. So I have only 2 cases. Either it is case 1 or it is case 2. And when it is or, it is plus. When it is and, it is into. Keep this logic in mind. So from 10 I have to choose 4. From 10 I have to choose 0, 10C0 and. So this is the first case. 0 boys and 4 girls. From 8 I have to choose 4. So it is 8C4. Or second case. Or means plus. From 10 I have to choose 1. 10C1 into. From 8 I have to choose 3. So it is 8C3. Do the calculations. 10C0 will give you 1. 8C4 will give you 70 plus 10C1 will give you 10 and 8C3 will give you 56. So this is 70 plus 560 which is equal to 630. Total number of selections is 630. Question number 12. A team of 8 players has to be selected from 14 players. In how many ways the selection can be made? A. If 2 particular players are always included. So first let us see what is given. From 14 we have to choose 8 players. From 14 if I have to choose 8, I would have told the answer is 14C8. But there is a restriction. Now the question is, in how many ways can the selection be made if question A says 2 particular players are always included. 2 particular players are always included. Out of 14, there are certain separate restriction for 2 people. So this 14 people, I'll divide them into 2 categories. One is the 2 people who should be included and the remaining are 12. These 2 people should be included. So selection of 2 people is over. I want to choose 8. 2 is over. Now from the other group, I need to get 6 more to make it a total of 8. So from here, I should get 6 more. So this is from 2 choosing 2 into 12C6. 2C2 you know is 1. So this will be equal to 12C6. Option B. 2 particular players are always excluded. Again, from the 14, 2 people condition is different, I'll put them in another group. The remaining 12, I'll put them here. Now what is the condition for these 2? They are always excluded. So they are rejected. So from here I don't have to choose anyone. So it is 0. That means how many more I have to choose? I have to choose totally 8. I have not yet chosen anyone. So I have to choose all the 8 from the second group. So all the 8 should come from here. So this 2C0 is only one way. So I can directly say the answer is, or the number of selections is equal to 12C8. From 12 choose 8. Answer is 12C8. Question 13. From a class of 9 boys and 7 girls, 12 students are to be chosen for a competition which includes at least 6 boys and at least 4 girls. In how many ways can this be done if one particular boy is always chosen? Let us look at what is given and what are all the conditions that has to be satisfied. We are told that there are 9 boys and 7 girls. I have to choose a total of 12 people. And what is my restriction? There should be at least 6 boys. Number of boys is 6 or more. There should be at least 4 girls. So number of girls is greater than or equal to 4. And there is one more condition. There is one particular boy who is always chosen. So in this there is 2 groups, that one boy who is always chosen and the remaining 8 boys. So when I make the different categories possible which is satisfying all these conditions, this one person is always chosen. Now what is the number of girls? It should be greater than or equal to 4. So let me start with 4. If there are 4 girls, one boy is already chosen, 1 plus 4 is 5. I want to make a total of 12, so I need 7 more from here. Next, this is not the only possibility. If I take 5 girls, this one has to be chosen. 5 plus 1, 6. I want to make a total of 12, so I need 6 more. Next possibility is, what if I take 6 girls? This is always chosen. 6 plus 1, 7. And here, to make it a total of 12, I need 5. What is my condition? Total boys should be greater than or equal to 6. 5 plus 1, this is the total number of boys. It is 6, so it is still satisfying the condition. Now what about the next one? If I take the next one here, there will be 7 girls. 1 is already chosen and this will be 4. Now the total number of boys will become 5. It does not satisfy this condition. So this is not possible. So these are the only 3 options. I have 3 cases. Now first case, this 1C1 is 1 itself. You need not write it. From 8 I have to choose 7 and from 7 I have to choose 4. Or, so put a plus sign, this is into, put a plus sign, from 8 I have to choose 6 and from 7 I have to choose 5. Or, I am moving to the third case, or means plus, from 8 I have to choose 5 and means into, from 7 I have to choose 6. So 7C6. Now calculate these values. 8C7 is 8, 7C4 is 35 plus 8C6 is 28, 7C5 is 21, 8C5 is 56 into 7. Multiply these, you will get 280 plus 588 plus 392, and this total will be equal to 1260. Question 14. A man has 10 relatives. 4 of them are ladies, 3 gentlemen and 3 children. In how many ways can he invite 7 relatives to a dinner party so that, and there are 3 sub-questions. A, there are exactly 2 ladies, 3 gentlemen and 2 children. We shall first see option A now. First, what is given? The main information. Totally, a man has 10 relatives, out of which 4 are ladies, 3 are gentlemen, and 3 are children. Option A says, how many selections can be done if he has to choose exactly 2 ladies, 3 gentlemen, and 2 children? So that is only one possibility. Let us calculate. Now there are 3 options, that's the only difference. From 4 you have to choose 2 and means into. From 3 you have to choose 3 and means again into. From 3 you have to choose 2. Do this calculation. 4C2 is 6, 3C3 is 1 and 3C2 is 3. So 6 into 3, total selections is 18. Option B, there are exactly 2 gentlemen and at least 3 ladies. Totally I have to choose 7 and there is exactly 2 gentlemen and there should be at least 3 ladies. At least 3 means greater than or equal to 3. That means it can be 3 or it can be 4. Now if this is 3, totally I have to choose 7, 3 plus 2, 5. So the remaining 2 should come from here. Greater than or equal to 3, it can also be 4, but this has to be exactly 2. 4 plus 2, 6. I want a total of 7. 1 more should come from this category. 2 cases, either the first one or the second one. Now the first one is from 4 choose 3 and means into. From 3 choose 2 and is into. From 3 choose 2. First case is over. Or second case, put a plus sign. Now you come to the second row. From 4 you choose 4 and from 3 you choose 2 and means into. Last one, from 3 you choose 1. 4C3 is equal to 4C1 and that is 4. This is 3C2 equivalent to 3C1 is 3 into 3. 4C4 is 1. 3C2 is same as 3C1. So 3 into 3 and that is 36 plus 9. The total number of selections is 45. Option C. In how many ways can you invite 7 people if there are exactly 3 children, at least 1 lady and at least 2 gentlemen? Children should be exactly 3. Gentlemen should be at least 2. At least 2 means it is greater than or equal to 2. Ladies should be at least 1. So it is greater than or equal to 1. If there are 3 here and greater than or equal to 1 possibility is 2 and the other possibility is 3. Children should be exactly 3. What should be the total? Total should be 7. So in the first case, 3 plus 2, 5. I need 2 more, so that is from here. See whether it is satisfying this condition. Yes. Next, 3 plus 3, 6. I need 1 more to make it 7. 1, it is satisfying the condition. So I get 2 cases. How to calculate the first one? From 4 choose 2. So 4C2 and from 3 choose 2. 3C2 and means into. From 3 choose 3. Or second case, or means plus. Here 1. From 4 choose 1 and from 3 choose 3 and from 3 choose 3. 4C2 is equal to 6. This is 3 and 1. 4C1 is 4 into 1 into 1. So this is 18 plus 4. The total number of selections is 22. Question 15. From a class of 12 boys and 10 girls, 10 students are to be chosen for a competition, including at least 4 boys and at least 4 girls. The 2 girls who won the prize last year should be included. In how many ways can the selections be made? Let us write down everything that is given first and then let us do the calculations. Now what is given? Totally there are 12 boys and there are 10 girls. And totally you have to choose 10 students for a competition. Now what is the restriction? There should be at least 4 boys and there should be at least 4 girls. So this should be greater than or equal to 4 and this also should be greater than or equal to 4. The restrictions are not over, there is one more. And what is that? The 2 girls who won the prize last year must be included. So in this there are 2 category of people. Out of the 10, split them. There are 2 who must be included always and there are the remaining 8. So satisfying all these conditions, how many selections can we make? Now since this should be greater than or equal to 4, let me start with 4 boys. These 2 girls must be selected. To make it a total of 10, 4 plus 2 is 6. I need 4 more from here. Now next let me take 5 boys. If I take 5 boys, this should be 2, have to be selected. 5 plus 2 is 7. I need 3 more from here to make it a total of 10. Next let me try the next option, 6. See whether it is satisfying, at least 4 girls and at least 4 boys. Now if this is 6, these 2 should be selected. 6 plus 2 is 8. To make it 10, I need 2 more. This is 4 and greater than or equal to 4. So you reached 4, so probably the next one. I need to be careful. If I make this 7, then I need 2 here must be selected. To make it a total of 10, I need 1 more. Then the total number of girls becomes 3, but I want them to be greater than or equal to 4. So this is not possible. So these are the only 3 possibilities. Now let us do the calculation. Either the first one or second one or third one, or means plus. Now what is the first one? Now from 2 you are choosing 2, from 2 you are choosing 2. From 2 choosing 2 is 1. Either you can write it or you need not write. It means the same because it does not affect your calculation. So this is 12C4 into 8C4. I will write it 2C2 plus, now the second row, from 12 choose 5, from 8 choose 3 and from 2 choose 2, or put a plus sign, from 12 choose 6 and from 8 choose 2 and from 2 you are choosing 2. Now we'll do the calculations. When you calculate, 12C4 will be 495, 8C4 will be 70 and this will be 1 plus 12C5 will be 792 into 8C3 will be 56 into 1 plus 12C6. 12C6 will be 924 into 8C2 will be 56 into 1. Let us do this calculations. Now this will be 34650 plus 44352 plus 25872. And when you add this you will get 104874. This is the total number of selections that can be done. Question number 16. A box contains 5 red, 4 black and 3 white balls. How many selections of 8 balls can be done if the selection contains option A, exactly 4 red, 2 black and 2 white balls? First let us work out option A now. Now what is given to us? A box contains 5 red, 4 black and 3 white balls. And the option A says how many selections are possible if I have to choose exactly 4 red, 2 black and 2 white. The total should be 8, 4, 2 and 2. Only one option. From 5 you have to choose 4 and from 4 you have to choose 2 and from 3 you have to choose 2. Let us do this calculation. 5C4 is 5 equivalent to 5C1 which is 5. 4C2 is 6 and 3C2 is equivalent to 3C1 which is 3. And here this is equal to 90. So the total number of selections is 90. Now let us look at option B. Option B says, how many selections are possible if there are at least 3 red? So there is a restriction now that the red should be at least 3. At least 3 means you know it is greater than or equal to 3. At least 2 black greater than or equal to 2 and at least 1 white. So this one is greater than or equal to 1. Now let us start here. Greater than or equal to 3, let me start with 3. When this is 3, what is the possibility for the next one? Black should be at least 3, red should be at least 3 and white should be at least 1. If this is 3, then the possibility for black is 3 or 4. So if this is 3, then this can be 3, or when this is 3, it can be 4 also. Note this. When this is 3, this can be either 3 or 4. I want a total of 8. 3 plus 3 is 6. So here I'll put 2 more. Here 7. To make it 8, I need 1 more. Now instead of 3, if I take 4. Now when this is 4, this again can be either 3 or it can be 4. So this can be 3 or this can be 4 when this is 4. 4 and 3 is 7. 7 and to make it a total of 8, I need 1 more. 4 and 4 is already 8, so this is 0, but the condition is at least 1. So this is not satisfying the condition, this is not possible. Now, red can be greater than or equal to 3 means it can be 3, 4 or 5. Just let us see for 5. Supposing this is 5, this should be 3 or 4. Again 5 plus 3, 8 is over, this should be 0. Not possible because this has to be greater than or equal to 1. So we are done with this one. We have only 3 cases. Now let us calculate the 3 cases. From 5 choose 3 and from 4 choose 3 and from 3 choose 2, first row. Or come to the second row, 5 choose 3 and from 4 choose 4 and from 3 choose 1. Or means plus. Come to the third calculation, 5 choose 4, that is 5C4 into second one, 4C3 into third one, 3C1 into 3C1. Now we'll write these calculations. This is equal to 10 into 4 into 3 plus 5C3 is 10. This is 1 and 3C1 is 3. 5C4 is 5 into 4 into 3. So if I do these calculations, this will give me 120 plus 30 plus 60 and add them, it is equal to 210. Total selections is 210. Question 17. An examination paper consists of 12 questions divided into 2 parts A and B, and they contain 7 questions in part A and part B contains 5 questions. We shall just write this information. There are 2 parts in the question paper, part A and part B, and part A has 7 questions and part B has 5 questions. a candidate is required to answer 8 questions. So totally 8 questions. And what is the condition? Selecting at least 3 from each of them. So this also should be greater than or equal to 3, and this also should be greater than or equal to 3. Let us see what are all the possibilities. If this has to be greater than or equal to 3, let me start with 3. To make it a total of 8, I need 5 more from here. Greater than or equal to 3. After 3, next option is 4. To make it a total of 8, I need 4 more here. Next one is 5. To make it a total of 8, I need 3 more here. Now, if I go for 6, to make it a total of 8, I need to put 2 more, but it should be greater than or equal to 3. Condition is failing, so this is not possible. Let us erase it off. So we get only 3 cases, first one or the second one or the third one. Please remember, or means plus and means into. So from 7 choose 3 and from 5 choose 5, or second case from 7 choose 4 and from 5 choose 4, and third case from 7 choose 5 and from 5 choose 3. You can calculate these values. You will get it as 35 into 1 plus 35 into 5 plus 21 into 10, and that is equal to 35 plus 175 plus 210, which is equal to 420. So the different selections possible are equal to 420. Question 18. A team of 11 is to be chosen out of 16 cricket players, of whom 4 are bowlers and 2 are wicket keepers. In how many ways can the team be chosen? If, first condition, there are exactly 3 bowlers and 1 wicket keeper, and the second condition is at least 3 bowlers and at least 1 wicket keeper. We shall see what is given to us. We have a total of 16 players. Total players is 16. Out of them, 4 are bowlers and 2 are wicket keepers. Now, totally there are 16. In that 16, 4 and 2. So, remaining are 10. 10 could be batsmen, all-rounders, whatever it is. So, let us write it as 10 is others. How should I make the selection? How many I have to choose? Is a cricket team, even otherwise we know we need 11 people for the team. And the condition is there should be exactly 3 bowlers, exactly 1 wicket keeper. I want a team of 11. 3 plus 1, 4 is over. To make it 11, I need 7 more. So the calculation, from 4 choose 3, and from 2 choose 1, and from 10 choose 7. Do the calculations. This is 4 into 2 into 120, and that will give you 960. The total selections is therefore equal to 960. Option B, we have to choose at least 3 bowlers. So this should be greater than or equal to 3, and at least 1 wicket keeper. So this should be greater than or equal to 1. Now at least 3. At least 3 means either 3 or 4. Now when this is 3, this is greater than or equal to 1. It can be 1 or 2 because total is 2 itself. So this can be 1 or it can be 2. So this is 3. I want to make a team of 11. 3 plus 1, 4, so I need 7 more. 3 plus 2, 5, to make it 11, I need 6 more. So these were the options when I had 3 bowlers. Now we'll go for 4. When I have 4, again I can have 1 and 2. So let us write this as 4 and write 1 and 2. 4 plus 1 is 5, so I need 6 more. 4 plus 2 is 6. And to make it 11, I need 5 more. Now let us write the calculations for this one and see what will be the answer. And do the calculations of these 4 cases. When we do the calculations of the first row, we get from 4 choose 3, from 2 choose 1, and from 10 choose 7. Or the second case, so plus, come to the second row, 4C3 into 2C2 into 10C6. Come to the third row, or, so put a plus here, from 4 choose 4, that is there here, and next one is from 2 choose 1, and from 10 you choose 6. Or come to the case in the fourth row, you have to choose 4, 2 and 5. Do the calculations, you will get these values, and the final answer will be equal to 2472. The total number of selections will be equal to 2472 after you add all the 4 cases and get the final answer. Question 19. Out of 4 officers and 10 clerks in an office, a committee of 2 officers and 3 clerks is to be formed. In how many ways can this be done? If any officer and any clerk can be included. So let us see option A. Totally there are 4 officers and 10 clerks, and we are asked to choose 2 officers and 3 clerks. In how many ways can this selection be done? From 4 you have to choose 2, and means into, from 10 you have to choose 3. I will do the calculation. This is 6 and this is 120, and this total is equal to 720. So the different selections possible is 720, and this is for option A. Option B. In how many ways can the selections be done if one particular clerk must be in the committee? One particular clerk must be in the committee. Split them as 9 and 1. Now, this one person is already selected. I need how many? I need 2 from here, 2 officers, and I need 3 clerks. Out of the 3, 1 is already chosen, so I need 2 more. So in how many ways can this be done? 4C2, and from 9 I have to choose 2, and from 1 I have to choose 1. So we'll do the calculations. 4C2 is 6, and this is 36, which is equal to 216. Let us look at option, this was option B. Now let us look at option C. Now what does option C say? According to option C, one particular officer must be in the committee. So totally there are 4 officers. Out of them, split them as 3 and 1. One person must be in the committee, and here there are 10. How many should I choose? I have to choose 2 officers. In the 2 officers, 1 is already chosen. So I need to choose 1 more from here. And how many clerks should I choose? Number of clerks is 3. So from 10 I have to choose 3. So what are the total number of ways? From 3 I have to choose 1. From 1 I have to choose 1. And from 10 I have to choose 3. Now this is 3 into 1 into 120, which is equal to 360. So number of selections for option C is 360. Just go through both the options. Question 20. A committee of 5 is to be formed from 8 Americans and 5 Anglo-Indians. In how many ways can this be done when the committee should contain exactly 2 Anglo-Indians? So let us see what is given. You have 8 Americans and you have 5 Anglo-Indians. You have to form a committee of 5, and the condition says, option A says, you should have exactly 2 Anglo-Indians. If you should have exactly 2 and you need a total of 5, I need 3 more, so they will be chosen from here, and then this will be equal to 8C3 into 5C2. Quickly do the calculations. This is 56 into 10, which is equal to 560. Total selections is 560. Option B, how many selections can be done if there should be at least 2 Anglo-Indians? So this should be at least 2. At least 2 means 2 or more. So it could be 2, 3, 4 or 5. I want a total of 5. So if it is 2, to make it 5, I need 3 more. To make it 5, I need 2 more. To make it 4, I need 1 more. And to make it 5, I need nothing else over. So this is 0 from here. Now how to do? There are how many options? Either the first one or second or third or fourth. Or means plus and means into. I'll quickly write the calculations directly for you. By now you should be familiar with the calculations. They are written directly for you. Just go through the calculations. 8C3 into 5C2. Next one is selection of 2 and 3. Third row is 1 and 4, and the fourth row is 0 and 5. When you calculate these values, you'll get 560, 280, 40 and 1. Add all the 4 cases. The total is 881 selections. Question 21. A candidate is required to answer 6 out of 12 questions, which are divided into 2 groups containing 6 questions in each group. Find the number of choices he has if he cannot answer more than 5 from any group. So let us see. A candidate is required to answer 6 out of 12 questions, which is divided into 2 groups, each containing 6 and 6 questions. Find the number of choices he has if he cannot write more than 5 from any. So that means total number of cases, here also less than or equal to 5, here also less than or equal to 5. And totally he has to answer how many questions? He has to answer a total of 6 questions. Let me start with the maximum, that is 5. If I have to write 5 questions here, then I need to attempt 1 from here to make it a total of 6. I cannot go more than 5, so I'll go less. 4. To make it 6, I need 2. And next one is 3. So to make it 6, I need 3 more. It is 2 here. To make it 6, it is 4. If it is 1, it is 5. Can I write 0? If it is 0, it will be 6 here, but that's not possible because it should be less than or equal to 5. So this is not possible. 1, 2, 3, 4 and 5. First case or second or third or fourth or fifth. I will write the calculations directly for you. I've written the calculations. First row 5 and 1, or second row, so plus 4 and 2, or 3 and 3, or 2 and 4, or means plus. The fourth case 1 and 5. You do these calculations of all these values, you'll get 36, 225, 400, 225 and 36, which is total of 922. So total number of selections is 922. With this, we have completed chapter 2, permutations and combinations. I hope you enjoyed this chapter as much as I enjoyed teaching this chapter. Thank you.